Everyone, so welcome to this session. This topic, I'm pretty sure that many of you, since you are from electronics and communication background, so you might not be comfortable in AC part. Okay, whenever we go for computing maximum power transfer, okay, to the load, okay, and we will be given different types of loads. So we face always kind of confusion, right? So what I decided was many students asked me as well, right, that please conduct one session on maximum power transfer. So I'm just going to give you, I'm going to solve one very important problem, right? And that is going to, take care of all the doubts that you had, okay? And please follow the same, okay, during the gate exam, because there is a chance that one question might be there, okay, from maximum power transfer. Okay, see, in gate examination, if you look at the network theory part, so computing power, there are different types of power, right? Okay, there is a real power, there is a reactive power, there is a complex power, apparent power, right? But when we talk about maximum power transfer, right? Okay, so here how do we compute maximum power transfer to the load? Okay, and what are the cases, what are the situation that we can have? तो क्या जरूरी है कि आपको सारे केस याद रखना? ये सारी चीजें हम देखेंगे, ठीक है? यू डोंट नीड टू मग अप एनी फॉर्मूला, ओके? क्योंकि होता क्या है, एग्जाम में आप फॉर्मूला याद करके जाते हैं तो आपको भूल जाता है, सिंपल है, ठीक है? तो लेट अस स्टार्ट आवर सेशन हियर, ओके? सो ये सेशन हमारा, एक बार मैं कंफर्म कर लेता हूँ मेरी वॉइस ऑडिबल है सबको कि नहीं, ठीक है? क्योंकि लाइव तो हो गए हैं बट नो बडी इज राइट नाउ, सो यू नीड टू कंफर्म इट, ठीक है? एक बार मैं देख लेता हूँ। आई थिंक एक मिनट में चेक कर। हाय नीरज, या हाँ हाँ, या माय वॉइस इज ऑडिबल। नीरज, तो वेरी शॉर्टली आई विल बी कंडक्टिंग सेशन ऑन मैथमेटिक्स, राइट? तो गेट डेटा साइंस के लिए भी मेरा प्लान है, ऐसा नहीं है, बिकॉज मैथमेटिक्स, दोज थ्री टॉपिक्स आर वेरी कॉमन, राइट? सो टुडे ओनली आई एम प्लानिंग इन द इवनिंग, ओके, आई विल बी अनाउंसिंग, सो डिपेंडिंग अपॉन द वोट, राइट? ठीक है, चलो। तो एक सिंपल सा प्रॉब्लम लेंगे, राइट? एंड आई विल शो यू द डिफरेंट काइंड ऑफ क्वेश्चन दे माइट आस्क यू फ्रॉम द सेम क्वेश्चन, राइट? तो देखो, जो प्रॉब्लम मैंने लिया है, सॉरी सी सेइंग वीडियो ऑडियो परफेक्ट, या थैंक यू मैन। ठीक है, तो आप देखोगे यहाँ पर कि आई एम जस्ट गोइंग टू टेक वन वेरी इंपॉर्टेंट एग्जाम्पल, राइट? ठीक है, then I will summarize also all the results, right? All the results I'm gonna summarize. Remember that uh, maximum power transfer is not at all difficult concept, right? ठीक है, अब होता क्या है कि we fail to identify, okay, what cases are given, right? And we need to recall also, we fail to recall the concept during the gate exam, क्योंकि हम लोगों को आदत है कि हाँ ठीक है, पावर इज नथिंग बट आई स्क्वायर आर, राइट? सिंपल। एंड द सेम फॉर्मूला आई एम गोना यूज हियर आल्सो, ठीक है? आप बस देखते जाओ कैसे क्या करते हैं, ठीक है? लेट मी मिनिमाइज माई सेल्फ, ओके? So the example that I have taken here is, let us say that you have got a source. Remember that source is there, okay? This is a source, okay? And we have got some kind of, you can say source impedance here, ठीक है? ये source impedance रहेगा. See the problem, okay? Directly we are going to solve the problem, okay? So this is given, and there is a load, okay? There is a load. I'm just going to take load as the complex load, right? You can say RL plus JXL, right? This is a load, and load is going to vary, okay? Load is going to vary. Whenever we talk about maximum power transfer, so the load has to vary, okay? Then only we can have the maximum power transfer to the load, right? So this is a structure, please remember that. Now in this load, RL plus JXL, you see here it is a complex load, right? Okay, we have been given a complex load. So what are the question they might ask you? क्या क्या क्वेश्चन आपसे पूछा जा सकता है, दैट यू हैव टू रिमेंबर, राइट? The input is nothing but your 100, you can say, volt, okay? This is a AC input, right? So the first question they might ask is, let us say that RL is fixed. Okay, see, load is given as RL plus JXL, right? But they might give you the value for RL equal to some value, right? If they are giving you RL equal to 10 ohm, it means what? What is the meaning of that? RL is fixed here. देखो, अगर RL की वैल्यू दी हुई है, if RL is given, okay, it means that RL is fixed. Now the question is, what is varying? What is varying? You have to find the P max. Okay, you have to find the P max. Okay, remember this. You have to find the P max when XL is changing, right? What is XL here? And you have to find the maximum power to the load, right? So in this case, RL is not changing, RL is fixed, right? Maximum power क्या होगा and XL की value क्या होगी, that you have to find. Now the second question they might ask is, second question, ठीक है, मैं आप लोगों का comment भी देखता जाऊंगा, you guys can keep commenting, ठीक है, जो भी question अगर होगा तो. Let us say XL is given. What is XL? You know, for XL is equal to minus J, ठीक है, minus J 10. Sorry, not J here. J should not be there, right? In case of XL, J should not be there. Only minus 10 we can take. Okay. Let's say XL is minus 10, or you can say 10 here, minus 10. Okay. And so what will be the RL and P max in this case? P max आपको निकालना है maximum power to the load and RL की value क्या होगी, right? Now in this case, see, in case of complex load, RL is given, XL is given, right? So XL can vary, RL can vary, right? But in this case, what is varying here is only RL is changing, right? This is not changing, it is again fixed. Please remember that. Now the third case that they might ask is, let's say RL and XL both vary. Third, RL and XL both varied, right? Then what is going to be the P max? आपका मैक्सिमम पावर ट्रांसफर क्या होगा एंड द वैल्यू ऑफ RL and XL? What is this? So these are the three conditions, these are the three questions they might ask you in GATE examination. Any one question, मतलब ऐसा नहीं है कि तीनों एक साथ देगा, ठीक है? Okay, I hope this makes sense. Hopefully this makes sense. And many students are not comfortable to solve this kind of question, right? ठीक है? RL is fixed, XL is changing, you have to find maximum power. XL is changing, XL is fixed, okay, that is kind of, you know, you can say inductive reactance in this case, right? Or capacitive reactance, whatever, ठीक है, आप -10 यहाँ पर है ना, so you don't have to worry about that, what is inductive or, you know, capacitive, just consider reactance, okay? P max is what, and what is the value of RL? Now let me explore everything, right? Like I will start with the very first one, right? You just take first one, okay? And let me give you the values also. So these values are given as J15. This is J15 ohm, and this is given as 10 ohm, right? Okay. So let me take first question. Okay. For RL is nothing but, you know, RL is fixed, okay? That is DC load is given, that is 10. Now, so let us draw the circuit now, okay? So what we can do here is, this is 100 volt. Please consider this as a RMS, okay? And we can make this like this, okay? See, it is given in, this circuit is given in parallel. You see here, this J15 and 10 is given in parallel, so we can simplify this, okay? We can find out its series combination, okay? So this will be the situation. You can say Ri and JXI, okay? And there is a load. Hopefully this makes sense, okay? So what we can do here is, we can find out Ri plus JXI. How to find that? आपको ये फाइंड करना पड़ेगा. तो कैसे फाइंड करेंगे? you can find here Ri plus Jxi is going to be J15 into 10 upon 10 plus J15. Please simplify this, okay? You will get the real part as well as the imaginary part, okay? You can just find out, okay, whatever. And so I'm not going to solve that. I'm just going to put directly the answer. So that will be nothing but your value. Let me give you 6.8 plus something, just a minute. Let me give that 6.8 plus J 4.9. This is approximate, okay? Please calculate properly, okay? So this is going to be what? Ri is nothing but 6.8 here, and this Xi is gonna be 4.9, you can say, ठीक है? Now what is varying in this case? क्या change हो रहा है? मैं आपको conclusion भी दूंगा, like I will be giving you the conclusion. Hi Devraj, good afternoon. Yes, ठीक है? Okay, so let me hide myself. I mean, make it small, otherwise many. Yeah. So you see guys, देखो आपने क्या किया, you just simplified this, ठीक है? ये part आपको simplify करना है. You got this, okay? Now XL is varying, RL is fixed, okay? XL is varying, RL is fixed. XL is varying, RL is fixed, okay? So what you have to do here is you have to find the maximum power transfer. When we can have the maximum power transfer? Tell me, when we can have the maximum power transfer? Think about it. RL is fixed, XL is not changing, like XL is changing, okay? So when we can have the maximum power transfer to the load? Can someone tell me? We can have maximum power to the load when there will be maximum current flowing through this, okay? Maximum current, अगर आपके लोड से मैक्सिमम करंट फ्लो होती है, इट मींस देयर विल बी मैक्सिमम पावर, ओके? प्लीज डू रिमेंबर दीज पॉइंट्स, ओके? सो मैक्सिमम करंट क्या हो सकता है? व्हाट कैन बी द मैक्सिमम करंट? एनीबॉडी? व्हाट कैन बी द मैक्सिमम करंट? व्हाट कैन बी द मैक्सिमम करंट? द मैक्सिमम करंट दैट वी कैन हैव इज आई मैक्स. आप देखते जाओ. सी दिस इज एक्सएल, ओके? Sorry, this is RL which is fixed. So what can be the maximum current? Maximum current is going to be 100 upon, okay, you can just take 100 upon, this is 100 upon Ri, okay, Ri, that is 6.8 plus 10, okay? Now the question is, you may be thinking, sir, why you haven't written Jxi and this XL? अच्छा ये बताओ, मैक्सिमम करंट कब फ्लो हो सकता है? व्हेन वी कैन हैव द मैक्सिमम करंट, when we can have the maximum current? Can you think about it? When there will be minimum, you can say impedance, right? Maximum current we want, right? So this XL, please do remember these points. These points are very important, right? So the maximum current we can find out directly, right? And maximum current जैसे ही आता है, you can say that this is nothing but 100 upon 16.8, and you can compute something, okay? So approximately we can say that that is 5.9 ampere, okay? So the power, maximum power is going to be this I max square times RL, right? Which is nothing but 5.9 whole square into RL is 10, okay? Which is nothing but, you can say 355, right? Please calculate everything properly because I don't have calculator, so I'm not going to calculate, ठीक है? अब देखो, आप सोचो मैंने क्या किया इस क्वेश्चन में. जब भी लोड कांस्टेंट गिवन रहेगा एंड एक्सएल इज चेंजिंग, रिमेंबर दैट, ओके? एक्सएल इज चेंजिंग, ओके? सो व्हाट यू हैव टू डू, you have to find the maximum current, and that too, when you find the maximum current, forget about these imaginary part, okay, and XL also, ठीक है? Just divide 100 by these real resistances, okay? Real part of the resistance, okay? Real part of the impedance, okay? Ri plus RL, okay? So you will get maximum and directly you can get the answer. No confusion should be there, okay? Please remember that point. Hopefully this makes sense. अब यहाँ से आप बता सकते हो what will be the XL. I think anybody can tell what will be the XL, right? So XL is going to be, Okay, what is going to be XL? XL is going to be this negative of XI, right? That is nothing but minus 4.9. Please remember that. Okay, then only we can have maximum power transfer, right? So in general I will give you the conclusion as well. फिर से मैं बता देता हूँ. What you have to keep in mind is you have to think like this. देखो, जब भी आपका whenever the very first condition is RL is fixed, okay, and the load is what? Ri plus jxi, okay. Sorry, source is this and your load is, you know, RL plus jxl, but it is fixed, okay, it is changing, and there is a source. Okay. So here XL has to be equal to minus XI for maximum power. Okay, maximum power transfer. You don't have to find out, right? Directly you should say, right? And what is maximum power, right? When we can have the maximum power, when there will be maximum current, I max. Okay, when we can have the maximum current, when the impedance is going to be small, right? When we can have the impedance is small. Okay, so this Vs upon Ri plus RL is the maximum current, okay? And simple है, power P max कैसे निकालते हैं? I max square times the load resistance RL. Forget about this XL, right? So in the complex load, the maximum power we can have is this. Very simple question, ठीक है? हाँ. You have to simplify this, okay? You have to make it like this, okay? It looks like a, you know, Thevenin equivalent, ठीक है? Next. अब नेक्स्ट सिचुएशन हमारी सेकंड आती है. व्हाट इज दैट सिचुएशन? प्लीज टेक अ लुक. आप देखोगे यहां पर फॉर एक्सेल इज -10, ओके, एंड नाउ व्हाट इज फिक्स्ड हियर? द रिएक्टेंस इज फिक्स्ड, ओके, द इमेजिनरी पार्ट ऑफ द लोड इज फिक्स्ड, राइट? नाउ व्हाट इज चेंजिंग हियर इज RL is changing, right? Second part of the question is XL is fixed. ये बहुत इंपॉर्टेंट है. RL is changing. What can be the maximum power transfer? You think the analog. देखो जो हमारा thinking process है, what is that? When we can have the maximum power, the maximum power we can have is when we can have the maximum current to the load. When we can have the maximum current to the load, okay, you have to think about it. ठीक है? When XL matches XI, okay, ठीक है, जब वो सेम रहेगा बट अपोजिट इन पोलैरिटी, राइट? आप नेगेटिव साइन लोगे, ठीक है? नेक्स्ट, तो फिर से मैं इस सर्किट ड्रॉ करता हूँ. सेम सर्किट है ना, 100. दिस इज रजिस्टर, यू कैन से दिस इज RI jXI, you can say 6.8, and this is 4.9. Now here we can say that what is fixed here? Tell me fast, what is fixed? XL is fixed, okay, and RL is changing, ठीक है? So आप यहाँ ऐसा बना सकते हो, जब भी XL is fixed, right, you can say that JXL, which is J minus J10, right, and RL is changing in this case. This is changing. Now this is a condition, okay? It's a very easy question. I'm just going to tell you a very easy way of computing RL, right? How to compute RL, what is the value of RL in this case, and what is P max. जब भी आपके एग्जाम में whenever complex load is given and they are saying that RL is fixed, please represent the load like this, J, XL and RL separately, and RL को आप vary करवाओ, ठीक है? Then you have to look back from here. Remember, you have to look back from here. इस पॉइंट से ऊपर देखना है. आप ऐसा सोचो कि हमारे पास only load RL is there, right? JXL is a part of that, ठीक है? Source impedance, ठीक है? ऐसा आप सोच सकते हो. Now, what is the value of RL? How can we say what is the value of RL? ठीक है? Condition समझो, XL is fixed, RL is changing, ठीक है? एंड एक्सएल की वैल्यू दी है -10. यस. So can you tell me what can be the power here? The power is going to be power I square RL, right? I you can say is flowing like this. So what is I here? I क्या होगा? You know, 100 upon. Okay, please consider this 100 as RMS. ठीक है? 100 upon कितना हो जाएगा? Can you tell me? 100 square. I square means 100 square. ठीक है? And the impedance, okay, so you see Ri is given here, right? So Ri plus what, 4.9, ये सारी चीजें दी हुई हैं, तो क्या हो जाएगा बताओ? 6 point okay. So we can write this as 6.8 plus RL whole square, that is the real part square, plus you just 4.9 and -10 कितना होता है? What is 4.9 plus minus that is 5.1, okay, square into what we have to multiply is, guys, RL only. RL we don't know. Okay, RL we don't know. You see, this is maximum power transfer, right? I mean, it is a power expression, not maximum power transfer. Then you might think that, okay sir, let us differentiate this and then we can find out the answer, right? Okay, but you think how much time you're going to consume. ठीक है, मैं इसको फिर से लिख देता हूँ एक बार. कैसे लिखते हैं बाई इंस्पेक्शन, प्लीज रिमेंबर दैट. यहाँ पर मैं सर्किट ड्रॉ कर रहा हूँ. आर आई जे एक्स आई, this is the resistance which is changing. This is jxl. Okay, let's say we want to say this is vs. Okay, what is p? Power expression, that is I square r. Okay, rl you can say. Okay, this is I. So we can write this as, you can say, vs square upon ri. Take ri, take rl whole square plus, you just add this xi plus xl, right? Xi plus xl whole square, okay, into RL. This is power expression, okay? Please do remember that. Now, how to maximize this? Okay, so what you will do here is you will try to maximize this power. So how to maximize power? dp by drl has to be equal to 0, right? You have to differentiate this with respect to RL. Okay, you have to differentiate this with respect to RL. Okay, and you think by yourself that when we can have the maximum power, that is a question. So remember that when you look from here, this point, आपको point दिख रहा होगा, इस पॉइंट से आपको देखना है इधर. Okay, take the magnitude of this impedance, that is going to be the value of RL, and at that RL you will get the maximum power transfer without differentiating and finding the value of RL. Remember this trick, remember this statement given by Dheeraj sir. What you have to do, look from this, wherever the RL is connected, look from there, go back to the source. Okay, that should consist of the imaginary part of the load also, right? So RL is going to be what? You have to take the magnitude of the impedance. Okay, that, okay, magnitude of the impedance. ठीक है, तो मैं फिर से यहाँ पर लिख देता हूँ. देखो, what you have to do, you have to look back from here, ठीक है, and take the magnitude of this impedance, right? What is the magnitude of this? You can say that Ri plus jxi plus xl. ठीक है, इसका आप मैग्नीट्यूड आप ले सकते हैं. Okay, so the magnitude, if you will take, so what will be the magnitude of this? कैसे find करते हैं magnitude, right? RL value is gonna be the magnitude of this impedance. Okay, at that value of RL, the maximum power is going to happen. ठीक है? Okay, so you can say that RL is going to be equal to square root of RI square plus XI plus XL का whole square. Very important. Okay, this is the value of RL where the maximum power transfer is going to happen. You put here, bus. You know already this. Okay, you will get the answer. Okay, so I'm just going to solve that. Let me come back to the question. So question क्या था? This was 100, right? Let me put all these values. 6.8 J, I believe that was कितना था? 4.9. You can say that this is given as minus J10, I believe. Yeah, yes. ठीक है. And RL we don't know. ठीक है, कोई दिक्कत नहीं, RL क्या होगा. So what we can find out, first of all we can find out the RL, right? So RL is nothing but what? Before we find out the maximum power transfer, we need to find out the RL, because in the gate exam they might ask you the question also ki what will be the maximum value of load. So the answer will be what? How to find directly? How to find directly? RL is going to be, okay, इस पॉइंट से आपको देखना है, इस पॉइंट से लुकिंग बैक द मैग्नीट्यूड ऑफ द टोटल impedance. RL is going to be the magnitude of total impedance. Okay, you have to look back to the network, so it will be the magnitude of the total impedance. What is magnitude? What is the impedance here? 6.8, right? So you can say that 6.8 plus J 4.9 minus J10. So square root of 6.8 whole square, and this is going to be what? 5.1. ठीक है, अब आप इसको सॉल्व कर सकते हैं. प्लीज सॉल्व दिस. ठीक है, सो यू विल गेट RL इज नियरली 8.38. ठीक है, आई होप दिस मेक्स सेंस टू एवरीवन, राइट? कि हाउ डू वी फाइंड आउट द RL? ओके, whenever XL is fixed, remember that RL is changing, so you have to look back. Okay, you have to go back and take the magnitude. Okay, find the magnitude or the norms, okay, of the impedance. ठीक है, तो टोटल इम्पिडेंस इज गोइंग टू बी दिस. क्योंकि ये फिक्स है तो इसको आप सोर्स में कंसीडर कर सकते हैं. ओके, so I hope this makes sense to all, right? So RL is 8.38. now you can plug back. Okay, you can plug back into the maximum power. Okay, so maximum power you will get here is like this. The P is going to be 100 square, okay, I square upon RI 6.8 plus 8.38 whole square 5.1 whole square, that is XL plus XI, okay, into RL. RL is 8.38. अब आप इसको सॉल्व कर लीजिए तो आंसर आ जाएगा. दिस इज मैक्सिमम पावर. आई थिंक नो कंफ्यूजन शुड बी देयर, राइट? सो approximately you will get 330. what? You can check it, okay, please. मैं आपको समराइज करने वाला हूं सारे. okay, let's say both are varied. okay, let's say both are varied. Let's say third case is when RL and XL both varied. What is the condition? जब दोनों वैरी करते हैं, रिमेंबर दैट फॉर मैक्सिमम पावर in this case, think about it, RL is has to be equal to RI and XL has to be equal to minus XI. Then only we can have the maximum power. Okay, then only we can have the maximum power. So you can say that since let's say ZS is given as RI plus JXI, okay, and ZL is nothing but RL plus JXL. So what is the relation between the two for maximum power transfer? For maximum power transfer, ZL has to be equal to ZS conjugate. Okay, you can say. ठीक है, ZS conjugate. Okay, it is also known as conjugate matching. Okay, conjugate matching you can say. Okay, for maximum power transfer, okay, whenever you know complex load is given, real part is changing, your imaginary part is also changing, so you have to exploit the conjugate matching. Okay, you have to go for conjugate matching. ठीक है, तो आपका जो ZL आएगा that will be ZS. Okay, so now if you add, like if you find the total impedance, right, so only you will get this plus this. Okay, these part will not be there, right, because they will get cancelled. So the maximum power, okay, P max is going to be what? P max is going to be, uh, it's a very simple situation, right? So the maximum power is going to be what? That will be V by, Ri plus RL, that is 2Ri, you can say, whole square, that is, I, okay, I square, okay, times RL. So RL, you can just RL is nothing but Ri only, right? So this is P max. तो यहाँ से आप बोल सकते हैं V स्क्वायर बाई 4Ri स्क्वायर टाइम्स Ri got cancel, V square by 4Ri. Okay, this is the, so V is 100 square times 4 into 6.8. I think it's a very easy question, right? ठीक है, so answer will be what? 364. होपफुली सबको ये समझ में आ गया होगा कैसे कर रहे हैं. ठीक है, so let me give you the recap. Okay, summary. आपको फॉर्मूले याद नहीं करना है सर. ओके, बहुत सारे लोग फॉर्मूले याद करके जाते हैं. समरी आप लोग याद रखो, समरी. ठीक है, मैं समरी दे देता हूं एक बार. देखो, आपके पास सोर्स एंड जो है वो फिक्स रहना चाहिए. सोर्स एंड राइट, एंड द लोड एंड. ओके, एंड कंडीशन फॉर मैक्सिमम पावर ट्रांसफर. यहां पर आप याद रख सकते हो, कंडीशन फॉर मैक्सिमम पावर ट्रांसफर. ठीक है, so let us say that source end में given है RS only, source and I'm talking about resistance, guys. Okay, resistance or impedance, right? I'm not talking about that source input. You can say that your input is fixed or kind of thing, right? Input load, input, you can say like excitation is fixed or what. I'm talking about resistance. Okay, source end में अगर source resistance is RS, right, which is fixed only, right? Your source resistance can be in the form of impedance also, right? It can be RS plus JXS like this. Third, it can be, please do remember these points, right? Right, these are the two cases that you can have here. Your source resistance can be pure resistance, or it can be the impedance also, right? Load. In case of load, it can be load RL. Okay, it can be load RL. It can be your complex load JL equal to RL plus JXL. These are the two cases that you can have always. ठीक है, now अब आपको पता है, अगर आप फर्स्ट केस की बात करें, लेट्स से RL is changing, okay, and source resistance is RS, right? What is the maximum power? What is the condition for maximum power transfer? देखो, गेट में डायरेक्ट क्वेश्चन आ जाते हैं. They will ask you what is the load resistance for maximum power transfer, and you have to look back to the network, and if your equivalent resistance is source equivalent resistance, you can say, yeah, source resistance is purely resistive, so the condition is going to be what? RL equal to RS. Simple, you have to find the equivalent resistance, guys. ठीक है, ये पॉइंट याद रखना. ठीक है, now in ZL equal to RL plus JXL. Okay, please do remember that. ठीक है, पहला केस आपको समझ में आ गया होगा कि RL equal to RS is the condition for maximum power transfer. Okay, maximum power transfer. Hopefully this makes sense to all. ठीक है, now the second condition that you can have is this: if load is complex, in this case थोड़ा सा इसको हम extend करेंगे. if load is complex, you can say ZL. Let me write properly. Okay, source and load end condition for मैक्सिमम पावर ट्रांसफर. अब आपको कभी भी डाउट नहीं आने वाला सर. ठीक है, जो लोग मगअप करते हैं कॉन्सेप्ट, राइट, मगअप मत करिए. ठीक है, इट टेक्स टाइम. इन फैक्ट इट टुक मी लाइक the time that I took to understand these things around 10 to 12 year, right? But आपको अभी समझ में आ जाएगा. Hardly it will take half an hour to watch. ठीक है. Now source end में let's say ZS is given as RS plus JXS, right? And load end is RL plus JXL. Now there is a condition, right? You can have only RL is varying, right? Only RL is varying, you can say. ठीक है. Only XL is varying. Okay, if they are saying only XL is varying means RL is fixed. If they are saying only RL is varying means what? XL is fixed. Both you can say that both RL and XL varies. Okay, it means what? That is ZL varies. Okay, overall ZL. Okay, okay. So अगर ये कंडीशन रहेगी, याद रखना, कंडीशन फॉर मैक्सिमम पावर ट्रांसफर, इफ लोड इज चेंजिंग बट योर एक्सेल इज फिक्स्ड, राइट? सो व्हाट यू हैव टू डू हियर इज यू हैव टू फाइंड द मैग्नीट्यूड ऑफ द ओवरऑल इंपिडेंस लुकिंग फ्रॉम द लोड. आप लोड से क्या करोगे? आरएल से यू हैव टू लुक फ्रॉम द लोड. आई टोल्ड यू ऑल्सो यू हैव टू लुक फ्रॉम द लोड. यहां से देखना है. आप देखो यहाँ पे, गो बैक एंड चेक किया. You have to look from here. ठीक है, and you take the magnitude of the total impedance. Magnitude of the total impedance, you know how to find magnitude. Okay, if complex things are given, right? Real part square plus imaginary part square. So in the language you have to mention, right? So your RL is going to be the magnitude of total impedance looking back from RL. ठीक है, चलो तो हम लिख सकते हैं, you take this and you take this guy. Okay, RL is changing now, forget about RL. Okay, so यहां से आपका RL कितना आ जाएगा? स्क्वायर रूट ऑफ RS प्लस RS प्लस. ठीक है, forget about RL, please ignore that. Don't consider RL. Since you are finding RL, then why will consider RL here, right? You have to take RS square plus X, take XS. Okay, XS plus XL का whole square. I hope this makes sense. ये पहला condition है. When this guy is, when XL is varying, जब XL आपका vary करेगा, ठीक है, and RL is fixed, in that case what will happen? In that case what will happen? I told you also, in that case for maximum power transfer, XL plus XI, the total reactance should be equal to 0. Okay, ठीक है, तो ये पहला केस है. दिस इज सेकंड केस. थर्ड, तो लेट मी टॉक अबाउट सेकंड. XL is varying, right? For maximum, the condition for maximum power transfer, XL plus XS has to be equal to 0. तो मतलब ये जब 0 होगा, it means don't consider it while computing the maximum power transfer, right? ठीक है, I hope this makes sense. Yeah, what is the meaning of that? It means XL has to be equal to minus XS. खत्म. Now the third case is when both are changing, right? When these, ZL, overall ZL is changing, that is nothing but a conjugate matching concept. So you can say that your ZL is going to be, load impedance is going to be ZS conjugate, right? ये conjugate matching है, conjugate matching for maximum power transfer. Okay. And एक और situation हो सकता है, that situation is important. One situation that we can have is, let's say that your ZS is RS plus JXS and your load is RL only. इस केस में कंडीशन क्या होगा? फिर से वही चीज है, since the load is purely resistive, okay, like you see this is RS plus JXS and there is a load, okay, RL, it is only changing. So you know that you look back, take the magnitude, right? So RL condition, the maximum power transfer condition for maximum power transfer is going to be the, take the magnitude of total impedance. अब यहां से देखोगे, यहां तो एक्सेल नहीं है, अच्छी बात है, एक्सेल होता तो वी नीड टू ऐड इट, राइट? सो इसका आपको मैग्नीट्यूड लेना है. सो आर एल इज गोइंग टू बी आर एस प्लस जे एक्सेस विच इज स्क्वायर रूट ऑफ आर एस स्क्वायर प्लस एक्सेस स्क्वायर. बहुत ही ईजी है. एंड वेन एवर यू वॉन्ट टू फाइंड मैक्सिमम पावर, रिमेंबर दैट you have to put, you have to take I square R only. And R में आपने notice किया होगा, that will be real part of the load, okay, RL always. Okay, so this was the story. There was a question in GATE examination, in EC paper, right? That question you guys can solve it. I can tell you also, but yeah. So EC में ये question आ चुका है, maximum power transfer. मैं आपको देखकर बता भी सकता हूँ. व्हाट वाज दैट क्वेश्चन? आई थिंक वन ऑफ द स्टूडेंट आस्क्ड मी. मैं देख लेता हूँ, ठीक है. अब इससे ज्यादा क्लैरिटी आपको कोई बताने वाला नहीं है, सब लोग फॉर्मूला ही बताते हैं, ठीक है, याद रखना. फॉर्मूला रटने से कोई फायदा नहीं है. इनफैक्ट मुझे भी फॉर्मूला बताया गया था एंड इन द एग्जाम वी फॉरगेट दैट फॉर्मूला. आपको तरीका पता होना चाहिए कब मैक्सिमम पावर होगा. थोड़ा फील करो यार, करंट मैक्सिमम कब होगा, and so many things. जब लोड आपका केवल वेरी हो रहा है, so you have to always take the load is equal to, the magnitude of the total impedance looking back from the load. Okay, please remember that when there is a XL changing, so XL मतलब आपको बस रिएक्टिव पार्ट को आपको ऐड कर देना है, रिएक्टिव, ठीक है, रिएक्टिव इंपेडेंस जो भी है. यस, एक क्वेश्चन था, ठीक है, मैं आपको बता देता हूँ क्वेश्चन क्या था, ठीक है. हम द क्वेश्चन वाज लाइक दिस. देखो क्वेश्चन नोट कर लो. द क्वेश्चन वाज इन द गिवन सर्किट द मैक्सिमम पावर दैट कैन बी ट्रांसफर टू द लोड RL, ठीक है, maximum power transferred to the load RL, right, is, देखो सर्किट कैसा दिया है. सर्किट इज गिवन लाइक दिस, 4 angle 0. See, they have given this is RMS, right? Yeah, it is RMS. Okay, please consider that. This is 2 ohm, J2 ohm, and there is a load RL like this. अभी RL बस दिया है guys. RL is given, right? Maximum power transfer load is changing here, right? Okay, so first of all what you have to do, आपको इसको पहले थेवनाइज करना पड़ेगा. प्लीज थेवनाइज इट. Okay, because you know that source resistance source impedance has to be in the form of Ri plus jxi. So इसको आपको convert करना पड़ेगा ना. तो इसको आप पहले convert करो. You have to convert into, VTH and then, ZTH and then there is the RL. Now they are asking only what is the condition for maximum power transfer? So answer will be RL equal to magnitude of ZTH. If they are asking what is the condition for maximum power transfer, so RL is nothing but magnitude of ZTH, right? Okay. Now how to find ZTH? You know that 2 ohm and J2 they are in parallel. Okay, please find out that. Okay. Okay, this question was asked in GATE. Remember guys, don't ignore it. बहुत सारे लोगों को नहीं बनेगा during exam pressure. Okay. Hopefully this makes sense. So I think this is clear, right? So directly आप बता सकते हो, ठीक है? ठीक है? And then since RL is changing, right? Since RL is changing, okay? So what is maximum power then, right? So the maximum power is going to be I square RL. Right? So I square क्या हो सकता है? VTH RMS जो आप find करोगे upon, you know, this is VTH. Not directly, don't take this directly, okay? That is mistake. You take this first. This is also RMS only when you will compute it, okay? You have to compute VTH. So you have to just take the magnitude of that square, okay, upon. Please take the magnitude of this, okay? And then you have to okay, V square, okay, or else let me write that. VTH RMS square upon, you know, or else square just you can forget for the moment. Okay. And then what you can say here is that what you can say, magnitude of this, right? Okay, so this and this means you have to add it. Okay, so you look back, okay, look back to the circuit that I discussed. Okay, maximum power के लिए क्या मैंने बताया था? When XL is changing, okay, sorry, when this is only there, right? So how do we find out? You see, we compute the magnitude of the total impedance, and then ये क्या मैंने किया है? ये आपका क्या है? What is this? Real part of the source impedance, and this is RL, okay, and this is also you have to consider. Everything you have to consider, right? ठीक है? I think this is clear. Okay. So it's a very easy part, and that you can do it. So मैं लिख देता हूँ directly. This is you know the value that, yeah. So you can consider this is, you will get here RTH plus JXTH, right? RTH plus RL का whole square plus, you know, XTH whole square, right? Okay. And this will be V square into RL. So RL कैसे compute करते हैं? RL is nothing but square root of, you know, RTH square plus XTH square. Simple magnitude, right? You will get the answer. So approximately what was the answer, guys, for this question? Let me write that answer. 1.66 omega, not omega, watt, right? Please remember that. Okay. So 1.66 watt is going to be the correct answer. Okay. So मैंने आपको सारा पढ़ा दिया है. I have taught you know, complete okay, and please consider this is a watt, right? क्योंकि you know signal and system is also in my mind right now, frequency domain and all. So सारी चीजें आ जाती हैं. Please remember these things, ठीक है? So how do we solve maximum power transfer? Gate में they will not ask you to compute. I don't think so. They might ask you to compute maximum power transfer. They will ask you to compute the condition for maximum power transfer. क्योंकि यार देखो गेट में ज़्यादा लेंदी क्वेश्चन नहीं आते हैं, याद रखना, ओके। दे विल नेवर आस्क क्वेश्चन लेंदी क्वेश्चंस, ओके। सो प्लीज फॉलो दिस मैक्सिमम पावर ट्रांसफर, ओके, थ्योरम, ठीक है। और जिसको जो भी डाउट है दे कैन रीच आउट टू मी ऑन माय व्हाट्सएप नंबर, राइट। और जो भी टॉपिक आपको अभी नहीं समझ आते हैं, सिंस वी हैव गॉट ओनली 3-4 days, राइट, 3 days ओनली, टुडे इज ट्यूसडे, वेडनेसडे, थर्सडे, फ्राइडे, right, 3 days, 3 to 4 days. So please keep revising. Today we are going to do mathematics, engineering mathematics for electronics people, as well as data science वाले भी, common जब रहेगा linear algebra, calculus and probability, they might join. But I'm just going to start with the multivariable first, ठीक है। सबको मल्टीवेरिएबल में ज़्यादा चैलेंजेस रहते हैं, तो आप समझ जाओ कि ये जो मैक्सिमम पावर ट्रांसफर है ना, ये काफ़ी इजी कॉन्सेप्ट है, राइट। गेट में दे विल नेवर आस्क यू टू, आई मीन दे माइट आस्क यू, बट क्योंकि थोड़ा लेंदी हो जाता है, दे माइट आस्क यू 1 mark क्वेश्चन कि व्हाट इज द कंडीशन फॉर मैक्सिमम पावर ट्रांसफर। प्लीज डू रिमेंबर दिस। थैंक यू, विल मीट इन द नेक्स्ट सेशन गाइस, कीप लर्निंग।